imported it into your database and generate report from there.
Yeah, are there like any other questions regarding the first version of Steve?
Or maybe the demo,
or maybe the demo, or well, if there are like no questions, then we move to like, okay, what the question is? Coffee, yeah, if you can write a plugin to make coffee, to make coffee. Well, basically, once we've done the system and we like use it in real life applications, we found out like a few limitations that we had in design. So right now we're working on a like second generation of Steve to resolve the issues. And one of the few issues which we found was with the current implementation of Steve is one is the complexity. Right now the inference engine, like we think if you want to add new stuff into that, the inference engine is already quite complex. And when you integrate these things, it's just a big piece of code which can be easily like broken, and you have to basically find dependencies and things when you put the new stuff in. So we're thinking of actually do a bit of decoupling. We want to separate the inference engine and the execution models and everything into like different parts, which we'll show in the next slide. The other thing is, even though Steve knows they can communicate to each other through the IRC, it was actually quite interesting thing to play with when we can see like different nodes to be able to talk to each other. But the thing which we realized is that it's still, there's no facility exists which we can use to like distribute the actual like attack among different nodes. It's just like they share the common information, they have their own execution rules, but there is no like control where you can say, yeah, I want this node to run scanner, and then I want this node to run the HTTP scanner, or I want to run this node and this node, both of them I want them to generate the scanning results and then compare it to find out the firewall rules. And another thing is, even though like the inference engine is quite smart, and it still does a bit of a dynamic thing and try to find the matching rules, but it's still just driven, and it's the rules are hard-coded. There is no way, like if you find out like one of the rules doesn't work, you cannot just kill one model and like replace the rule and like let the model run again. You have to like shut down the whole system and then start it up again. And we felt it was a bit of limitation, so we want to resolve that as well. And also for the knowledge interchange format thing. Right now, this the Steve format, it only represents the network layout thing and the things which are related to the like IP network. But what we realized, aside from the IP network, it's also good to like, especially during the information gathering phase, you also want to find out like what people exist within the target network or like target organization. You want to find the links between them. You also want to find the branches and like how they link between each other, and then link it to the IP network. So we felt like the original Steve format had this limitation, so we are working on like extending that as well.
Yeah, well, regarding the functionality decoupling, right now we have this big piece of code which contains all of this, yeah, different engine, knowledge base, publisher, importer, and console. What we want to move to is we want to move to a multi-agent architecture where you would have each of these subsystems as an independent agent, which could be run either over the network or maybe locally on the host, which would give you the ability to actually unplug each part of the system, unplug each agent at any given time, and then plug it back in.
And tune it like separately.
Yeah.
Yeah, basically the current diagram of the Steve is like this big square. So you can see like all the components are still like part of the single program. Yeah, and basically we had a few other like targets which we want to achieve, like in a second generation of Steve. One is we wanted to make like platform independent, which means not only like a mobile platform which you can do with Java, but we also want it to be like a language independent. And the way we want to like address this is by introducing the messaging framework. So what we'll have to do is to port this messaging. Well, one of the things is a common protocol basically. The common protocol is just the protocol which the Steve agents can talk over the network. So it's not like a single process right now when you have to use certain API to be able to like add your own tool. All you have to do is to be able to follow like certain protocols, so you can code either the protocol thing, or you can use our like framework in whatever language you like. And then right now, like the second generation of Steve is composed of agents. They're like completely independent agents. They can be run on the same box, or they can run on different like systems. They can even run on different networks, and all you have to do is to tell them how to communicate to each other. And the only thing which they need to know is the main node, the node which carries the naming service, which we'll talk about a bit later. Yeah, and the other thing which they have to follow the messaging protocol which we are designing. Right now we're using the FIPA protocol, which is like soon to be standard protocol for like agent communication, but we feel it doesn't really fit into our needs, so we want to develop like our own extension of the thing. Yeah, and one of the key things in the second version of Snort, initially we only had this event-driven like execution flow when you see a certain type of data and you want to execute the thing. But sometimes you don't have like any input data, but you want to give like a goal to the agent or a goal to the system. Like, yeah, I want to compromise this network, and then you want the system to run until it actually achieves the goal. So what we have is a capability thing where each tool or each like a tool wrapper which can wrap a single tool or like multiple tools is assigned like a number of capabilities. Capabilities is basically what the tool can do, and then we have a matching system which will like do the capability matching, and we'll introduce like in more detail like on next slide. Yeah, so the second version of Steve has like architecture which will look roughly like this. Right now we have implemented the naming service. For the message exchange framework, right now we use a standard package which implements the FIPA message exchanging, but we want to replace it with our implementation. And we have tool wrappers where like you just have like an nmap daemon which will just like sit on the system and listen for the connections. And then whenever you need like once the tool is started, it has to register itself with information lookup service where it registers the capabilities which the tool can do. For example, if it's an nmap daemon, it can do like scan, it can do TCP scan, it can do UDP scan, it can do like sweep. All these capabilities you like pick them up yourself. The only thing is within the Steve framework there should be some agreement. So when certain tool registers the capabilities, the other tools should know if they need like to implement the scan, they have to look for the like scan capable like agents. And we also have interest list, which is also supposed to be registered within the information lookup service. The interest list is a type of data which the tool is interested, or the type of data which the tool can take as an input, so it can start the execution. In the first version of the tool, that was the Steve message which should be matched in order to trigger the execution of certain tool. And in the second version, we moved to the point so it actually becomes an interest. So when the event generates with a certain type of data, each agent should look up for the agents which are interested in this sort of data and pass the data to the agent. Yeah, and we also have like the console agent. In the first version, it was just interface. Right now, the console agent is just a separate agent, and for the user interface, all you have to do is like to implement your own program and follow the protocol to talk to the Steve system.
Message exchange framework, we wanted to make it abstract. That is, we will not be really bound to the, for example, TCP or UDP. The whole message exchange framework would be implemented in such a way that it could be, for example, implemented as a plain TCP connection, UDP. It could be done over ICMP. We were also thinking about doing this also through instant messaging. And another thing that we are thinking of doing is using stenography And additionally, we wanted to implement the SMTP and POP3 communication. That is, you send all the messages and all the exchange is taking place over the SMTP and retrieved via POP3.
Yeah, so basically when two agents, they're using like the message exchange framework, the communication with the message exchange framework is transparent, it's just the API. Of course you can implement your own protocol, but then you have to also like follow up with all these covert channels which might be in use. By default, right now we're just using like a plain HTTP connection. It's basically two agents that you talk to each other using HTTP, but you can also encapsulate this into other like protocols, so you can create like covert channels and tunneling, and this stuff is absolutely transparent to the agent. The only thing agent needs to do is to look up for the name of the other agent, to talk to the naming service, and use the API to send and receive the messages. Everything else is transparent.
The goal-driven execution is that it's like a term taken from multi-agents. Basically, the idea is that each agent will describe its functionality with a set of capabilities. That is, what that tool can actually do, what this agent can do, and on what type of objects it can do the following actions. And then each agent is given a task to execute that particular capability on that particular object, and then this becomes agent goals, and the agent will now, using all of its capabilities, have to try to achieve the goal. And that's the idea behind the multi-agent architecture of Steve 2.
Yeah, and basically each agent, it also maintains like a library of plans how it can achieve a certain goal. For example, if you need to penetrate a network, there are, I think it would be a number of ways what you can do, like what sort of activity you can initiate to penetrate the network. You can like do the sweep scan first, or you can do just like scans on port 80s, or you can do like a regular scan. And agent, it will have like a plan of a library of plans, and it should like pick up one plan, and it will try to execute it. If the plan fails, it maintains the plan execution succession rate. So it will try the other plan, and this plan will like have 1 minus. So next time when it needs to pick up the first plan, it will pick up the plan which was successful the most of the times. And this way we can have the execution flow, which is not fixed to like a particular hard-coded execution scheme that we had in the first version of Steve. So each time the execution happens, we have certain degree of randomness, but within the scenarios which I described by the security analysts. And also the other things which can affect the plan selection, not all penetrations can be like direct, straight. So we have implemented certain environment settings in the system. So right now it's just a latency, like which means which states like how long this plan would take to be executed. And if the requirement of the current environment is to have the plan to be executed as fast as possible, the plans which have like shorter like latency time will be executed. And we also have like stealthness. If the plan is like to run a very noisy scan, maybe the agent will pick up the other plan for this particular like scanning attack.
And we're also going to have, besides that, event-driven execution flow. That is, each agent may be subscribed to different interests. That is, it can express its interest in certain types of data that it should receive, it should be subscribed to. And as soon as this type of data arrives, the agent will be notified, and this event will be delivered to the agent. And whenever the agent discovers new data, the interest list is queried for all of the agents that are actually interested in that data, and then the agent would be responsible for actually forwarding that data to all the interested peers.
Yeah, as you saw the diagram, there was like information lookup service. So all the queries for the interest, when agent starts, it should register its own interest in that system, register capabilities as well. And whenever new data appears, the agent looks who is interested in this sort of data and just forwards the data to the agent. So this way we almost